Okay, question 3. Okay, so in question 3, we are trying to again look back at the concept of applying KVL and KCL. Okay, given a set of current direction and voltage drops. All right, so how do you apply it over here? Okay, so the way to do this is you put a loop. So if I draw a loop, okay, from your material, from the studio, we understand that in a KVL, the voltage drops in the same direction will be equal to the voltage drop in the opposite direction. Okay, so what is source, what is producing power, what is consuming power, that is another thing. Okay, but when you draw the loop, okay, anything in that same direction is considered to be equal to everything in the opposite direction. Okay, so if I look at this loop over here, you can see that this loop is clockwise. So plus is here, minus is here, plus is here, minus here. That means as far as R3 and V1 is concerned, based on this clockwise loop that I've drawn, current will flow in this clockwise direction. Okay, that means we are both following the direction of my loop. So I can say V1 plus VR3. Okay, whereas VR1, okay, over here VR1 and VR2 are both opposite to my direction of the loop. Okay, they're opposite to my direction of the loop. So I say that is equals to VR1 plus VR2. Okay, so when I draw this loop, okay, the expression I'll get is this, which means I can rewrite it as V1 plus VR3 minus VR1 minus VR2 equals to 0. Okay, so that is this one over here. So in terms of voltage, you can see that this is correct for the first loop. Now for the second loop, okay, so I can draw again in any direction I like. Okay, you can draw this way or the other way. Both way is fine. Okay. Again, why I'm drawing this way is because since the supply is already this way, I'm going to draw it in this way. And again, you look at the direction of the loop that you have drawn with the plus minus already given to us. So you can see that this is in the direction of the loop. This is in the direction of the loop, V2 and VR4, whereas VR2 and VR5 are in the opposite direction. They are in the opposite direction of my loop. Okay, so the same direction, opposite direction, the way I look at it is, imagine this loop is the current flow. So for both V2 and VR4, current is coming out of the positive, current is coming out of the positive. For VR2 and VR5, current is going into the positive. Okay, so that is how you look at those that are in the same direction of the loop and those that are in the opposite direction of the loop. Okay, so with that, you can write the same another expression over here, V2 plus VR4 equals to VR2 plus VR5. Okay, so I can do it this way, minus VR2 minus VR5 equals to 0. Okay, which means that this is also correct. So in terms of the KVL equations, B and C are both correct. Okay, so that's for KVL. For KCL, we just look at the direction of the arrows already given to us. So here you can see that this is IR1, this is IR2, and this is IR4. Okay, so if I look at this node over here, node A, I can say that IR1 is equals to IR2 plus IR4, which is this one, correct? If I move everything to the left hand side, is this. So this is correct. So KCL, that first expression is correct. IR2, so IR1 plus IR3 equals to 0. Now, where is IR1 and IR3? IR3, they are both actually on the same branch here, this same wire on the left hand side. Okay, so in this same wire, you can see that I have drawn IR1 in this way, and I've drawn IR3 in this way, but only one of it is correct. Okay, only one of it is correct. That means one is opposite the other, because current cannot be flowing both this way and this way at the same time, correct? It's either going clockwise or it's going anti-clockwise in this branch over here. Okay, so because of that, okay, we can say that IR1 is equals to negative IR3. Okay, either one is correct, so the other one is the opposite direction. So with that, you can say that this is also correct. Okay, and the same thinking applies for this, where you have IR4 and IR5. So IR4 is going this direction. IR5 is also going in the opposite direction. Okay, so you can see that they are both in the same branch but going in opposite direction, same as IR1 and IR3. The same branch but going in opposite direction. So with that, you can also say the IR4 is equals to negative IR5. Okay, they are both same currents or currents in the same branch but going in opposite direction. So only one of it is correct. So with that, you can also say that IR4 is equals or plus IR5 equals to 0. Okay, so both of the first three KCL expressions are correct. The last one is relating to this node B. So if you look at node B, you can say that current coming in is IR3, IR2, going out is IR5. Okay, so at node B, you can say the IR3 plus IR2 equals to IR5. So this is wrong. Okay, the last one for KCL is wrong. So the correct option for both KVL and KCL is B. All right, so that is how you analyze this question here.